In a previous video lecture, I described how one determines the x components of a vector, four different situations corresponding to vectors pointing into the first, the second, the third, and the fourth quadrants. Now we'll talk about how one determines the y components of a vector. Once again, I show four different quadrants. Let's talk about quadrant number one. The vector points into the first quadrant, making an angle of theta with respect to the positive x-axis. The y component of this vector can be visualized as the shadow cast on the positive y-axis if a light source is placed to the right of the vector. The shadow is shown as a broken red line. Because that shadow lies along the positive y-axis, the y component of this vector will be a positive quantity. It will be positive times the leg height shown in red. The leg height there is the same as the height of the leg there, and it's the side that's opposite the angle theta. So using SOHCAHTOA and the sine function, we have a subscript y, the y component of a, equaling a sine theta. Next, I show a vector pointing into the second quadrant, making an angle of theta with respect to the negative x-axis. The y component of this vector can be visualized as a shadow that's cast on the positive y-axis if a light beam is placed to the left of this vector b. Because the shadow is cast along the positive y-axis, the y component of this vector will be positive times the height of that leg. The leg height there is the same as the height shown there, which is the side opposite the angle theta. So the sine function is operational here. And so the y component of the vector is positive b sine theta. Third quadrant. A vector pointing into the third quadrant makes an angle theta with respect to the negative y-axis. The y component of this vector can be imagined to be the shadow, plus or minus, the length of the shadow cast by a light source placed here, directing its beam this way. The shadow is cast along the negative y-axis, so the y component of the c vector will be a negative number, and it's the negative of that leg height. That leg height there is the same as that one, which is the side opposite the angle theta, so we use the sine function in SOHCAHTOA to get c subscript y equal negative c sine theta. One more to go. A vector pointing into the into the fourth quadrant, making an angle theta with respect to the x-axis. A light source over here to the right of the arrow, cast a shadow along the negative y-axis. Consequently, the y component of this vector d will be a negative, and in this case, negative d sine theta. That's all I have for you regarding y components. When next we look at vectors, we'll learn how to add two or more vectors.